Today I thought we'd do something a little bit different. I've got, well, a Samson Meteor mic, and this is the mic that I use for most of the recordings that you hear. So whenever I do like a little review or something, and I have a voiceover, this is the microphone I use. It's cheap, it's affordable, it's only like $60. You can get it, I think it might be $50 now, but either way. Basically it's broken, so the microphone itself doesn't work, but obviously the audio interface works perfectly fine. So that means that the circuitry isn't bad. Somewhere there is a problem with the microphone itself, the actual condenser, and I've already taken it apart, unfortunately, so I already know what the solution is. The op amp inside has broken off a lead, because the weird way that they put this together is that they don't use a board. It's hard to explain. For the op amp, they don't use a board. Instead, they decided that it would be a great idea to use an entire, like they just hang the entire wire off of the op amp itself. And you'll see that in just a minute. I was delaying for time there. That's why I was kind of hesitating, because I'm looking for a screwdriver. So let's go ahead and open it. On each side there are screws. If you're wondering, yours is broken too. Each side there are screws. You don't need to take the legs off for this, but you can if you want to. Not really necessary. It may even help you to leave them on. So each side there are 2 screws, and then this condenser just wobbles off. You'll see in a second. Hope that doesn't focus. I need like a monitor for this camera so I can see whether things are in focus. That's the next upgrade. There we go. I guess I should use a handle. So there we are. Right. Now, taking those off, I'm going to put these aside, these little screws. I'm going to move this right like that, and you'll see the problem right away. So, and you can tell I've already tried to solder that back together, but no luck was found there. See if I can get it in focus without having to really zoom in or anything like that. Okay. So, as you'll see, this is the op amp that we need to replace. It's missing a lead right there, and basically how this used to work is they just wire the entire lead of the microphone onto this op amp and just leave it floating there. Instead of having a trace, like, I don't know why they didn't do this. It's a multi-layer circuit board, you know, it's a multi-layer PCB, yet they didn't decide to have a little trace lead here and then solder the wire into a little hole, you know, like a little pad. For some reason they just lifted the leg and then soldered it directly to the leg. So if you drop this microphone enough, which I've done, that leg could break off, and that's kind of silly. I'm debating whether or not to make a board, but then I'd still have to do the same thing. So I guess the only thing I can really do is replace that. It's unfortunate because it would have been great if they had made one right for there. But either way, that's what I'm going to have to do, is go ahead and replace that. So first thing that I'm going to try to do is just sort of flow all the leads on that op amp itself, so it'll kind of make it easier to take off. Hopefully. Let's make sure I've got the right tip for the soldering iron. And then we'll work from there. So the first, I can't really see because I'm trying to maintain this perspective so you can see, but that's usually the way it goes, eh? So I'm going to add a little bit to each one, and then basically from there we'll take them off. We're being counterproductive so we can be productive in a weird way. The real reason it's coming off is because there's flux in the solder, and I could probably just apply flux, but I don't have any at the moment. That's the honest truth of the matter. I don't have any flux, so we're just basically just running solder to each of these points, and it doesn't matter if I bridge them right now, because we're going to be taking that off. And I can't use the handy tool here because they are not through-hole things, so we're going to be using braid. Or, I don't know whether braid, I think you call it, wick. Solder wick is what you could call it too. Bring the light in. Does that help a little bit? Maybe that makes it easier to see. Not really sure. It's easy for you to see. I'm looking at the perspective of the screen and it's like, wow, that's a great perspective. And then from my perspective, it's like looking around, looking through a rear view mirror. Going, is that good? I don't know. This is going to be difficult. I can't really see. I may have to even pause the video. Sometimes I do that because I can't see what I'm doing with the camera in its current position. Well, that looks not too bad from what I can see. We're just taking it off. Oh, this is even worse. Let's see if I can rotate it. That makes it a little bit better. So this kind of thing is always tough, getting these tiny leads off. Another thing you can use is a similar solder sucker. I suppose I could use the solder sucker too. That would work for this too, but maybe I will, but we'll see how it goes. Okay, let me take a look at that real quick, see what we've done. Okay, so we've got one side off. Here, let me go get a screwdriver, a little narrow screwdriver. Sorry, I won't get a screwdriver, I'll get my new pair of tweezers. Give me a minute. So I think some of these leads are doing alright. Let's see. Does almost look like they just broke free, but it's hard to really tell. Always tough, isn't it? It's never an easy operation. Right in there. This is the kind of job you could use what would you call it? Not a heat gun. Oh, there's one leg. Not a heat gun, but a, I guess it's a heat gun. You know the thing I'm talking about. No, you don't. There we go, there's the other one coming up there. You don't want to lift the pad, you just want to make sure that it's coming off. I don't know about this one, I didn't touch that one yet. Yeah, it's just a heat gun. So basically what I'm doing here is I'm just applying heat to the wick and trying to soak up any remaining solder. Mostly it's taken off for the most part. You never want to apply too much heat. Right now I'm at 440 degrees Celsius. That's pretty hot, but keep in mind that it's not as hot as something like a good Weller or what's the other brand? Hakko. I think Hakko is the name of it. Mine's a cheap Chinese knockoff, so the retaining of heat is nowhere near as good. Okay, so we got that whole side off. Don't know if you can see that. I'm going to try to zoom in just a touch here. Oh, we're all the way in. Got the wrong lens, whatever, it's a wide angle. So we can see that this is moving a little bit on this side, so this is the other side that we just need to take off. So again, I would say if you're using probably like a Weller, you probably only need like 300 degrees. You don't want to burn off these pads, but you do need some heat, obviously. You don't want to go too cold and then you'll be sitting there doing nothing forever and then you'll be just actually tearing at them, which is bad too. I've done that. So yeah, that's what I thought. We could probably move this just by applying pressure because the other side's completely taken off. Oop. Trying to get that in there. There we go. I knew we didn't really need it, so I'm just going to take that out there. There we are. So there's a little op amp. Let me zoom in for you. Ooh, see if we can get that in focus. So there's a little op amp. I'll have in the description what this op amp is, so if this should happen to you, that you lose the lead on this, I'll have in the description the type of op amp that you need to get. And I'll go ahead and get the other one. It's out of the package. What are we running at? 10 minutes? So I'll pause the video here and I'll be right back in just a second. So here it is right here. It came in, it's a Max 4477 ASA ND. I'll have that in the description from where I got it. I got it off DigiKey. That's basically the Canadian version of Mouser. They have it on Mouser too, I checked, but the shipping is insane there, so I didn't bother. Hopefully you can see this. The wintertime anti-static could actually be an issue with this. So be careful, ground yourself, all that good stuff, if it's the winter. What are we looking at here? There we go. Because this kind of component is not really anti-static. And there it is, a tiny little guy right there. Alright, let's see if we can move it down to the edge so we don't have to reach into the bag. Oh, I'll just reach into the bag. There we go. So, now I'm just going to hold that right there. Oop. So there's our old one. Let's see if we can get this here. Oof. So there's our old one right here. I don't know if you can see it. And there's a new one. Nice and fresh. And the key to these is you gotta locate where the dot is in the upper, I think it's the upper right hand corner. Just locate the dot and it should correspond on the board. It's pretty simple to get. Let's see where that is actually. I don't really know. There it is. I see it. So, and I can figure it out too if I need to. So let's see. Sorry, just making sure I know that that's where the dot is. It's hiding itself a little bit. Okay, I figured it out. So let's go ahead and first off, before we do anything, let's zoom in again here. What we'll do is we'll tin all those points because they're a little bit crummy now that we've done all that on them. So we'll go ahead and add some solder to those points, make sure they're nice and ready to receive, so to speak, so that we can just sink it down in there. Trying to get a good angle for you here without covering your view. But it looks like I'm going to have to for these ones. I'm pretty slow, aren't I? That's okay, I guess. Oof, that was bad. We don't need that much. Okay. Ugh, let me see here. I need to be able to see. I can't see. I'll have to do some extra research. Either way, so yeah, we burnt off some pins there, but it can happen. Luckily for us, this isn't too bad. We can see that this trace clearly goes back to here, so we can just run a line right here to here. For this one, I'm pretty sure it's a ground. Let me make sure of that by checking the other one here. I'm not 100% sure. I will check again in just a minute, but pretty sure of it. I will check each of the pins here. Okay, so that was it. So that one was our ground pin. So I think that, I'm not really sure what that one would be. I'll have to look into it and see what it was. In just a little bit, I'll do that off camera, just figure it out. Okay, well for now though, what we'll do is we'll just place this on. I should probably use the tweezers, that would be better, wouldn't it? And we'll try to sink it in. I'm just going to sink it into one of the corners there. And then once I've got it on one of them, I can probably get it in for the rest. So we'll do that in just a second. This is bad, dude. This is not the most quality I've done, but what can I say? This is tough. Trying to melt those. Oops. Yeah, that's quality of work I've done here. But what can I say here? Okay, that's 2 there. It's tough to avoid that wire there. Okay, so I need to run this pin here back to there, which I will do in a little bit. It's not very straight now, is it? Okay, well, either way, those go to there. This one has to have a little lead that goes over to there. As for the bottom one, I'll figure that out. That's not a very good job. Jeez. See if I can do that better. See if I can see this here, how bad I did. Ooh, that was not very good. Okay, so we burnt out that pin. So let's go ahead. I'm going to take some wire. I'm going to take, I guess just yellow would be good. I don't really know. Or green. Maybe green's nice. Doesn't matter. Let's see. We'll just take a little bit of a strip here. And we'll just run a lead back from there to there. And hopefully that will be good. I could also use some of this really cheap stuff. That might stick a little better. Well, whatever, we'll use the good stuff, I guess. So there we are there. There we are there. Now, we'll just cut this like that. Put this on like here. Basically, what you're seeing is because of the convenience of the setup, I can just plug on a lav mic and then turn on the camera. You're seeing some of the things that I'll just try and attempt to fix. I don't even know if this will work necessarily, but I'm going to try it. It's something I have broken and I need to get fixed, so I'm going to try it. This one I'm going to tin a little bit, just add a little bit to the leg here so that I can, man, if there's one time a chisel tip would probably, let me bring it back so I can see it here. I need to be able to see this. I'll zoom out a bit so you get a general picture at least of what I'm doing. I'm just soldering the lead over here. I know it's a little out of shot, so just going to try to get that in here. Still the best idea would be to have the arm. I still want the camera to be on an arm, so I can just freely move the arm around depending on where I need it to be. So that would be the idea, the ideal situation, so that I could just, oh well, the camera needs to be here, well I'll move the arm around and you can get the perfect angle so I can work while you watch without me having to do a lot of guesswork as to where everything is and just sort of going from there. Oops. Because right now I can't really see. No, it's not on the leg. So after I went away, I looked at the schematic because I plugged it in and it didn't work. And I was like, well, okay, what happened? It's probably one of these, it's probably this lead that I thought right here. So I looked at the schematic to see what that lead was, and I realized that this is the, like I said earlier, the ASA 4477 or something. And the original, which is over there, is the ASA 4475. So the leads are completely different. So I changed up the leads the way they could be, just by soldering some wires just to see if it works. Obviously this isn't a great solution, but I soldered it together. It still doesn't work. I get a blank, virtually blank signal. It's just like a weird white noise. It makes just weird USB sounds. The LED still comes on red, like there's no input. And that's basically that. If I wanted to do this again and solder it directly to the board, I'd have to get the 4488, which is the currently running version of the 4475, because the 4475 is like discontinued. So the 4478 is what you would want to get if you wanted to do this repair. Personally, I don't know if it's worth it. It's only $1, but I don't know. I'll look around local tech stores and see if they have it in stock. If they don't, I'm not going to bother ordering it, because I don't think it's worth it. But basically, if you get the 4488, then you can just solder it directly on and not worry about it. This one, I got the wrong one. So there you go. You get to see some mistakes I made. We burnt off a pin or two right there. We burnt off 2 pads. Those were easy to mend, though. Yeah. Sorry about that disappointment. But there you go. You got to come along and see the mistakes, and you learn, hopefully, something from that. So as you can see here, I ended up getting the new chip, and so, well, you hear it working right now. It's a little bit low because I have to get in there, but you can see it working right now. And that's all there was to it. I just ended up having to, I got the wrong chip earlier. It was a 775. It was a 775. Sorry, the 4475, and I ended up getting the 4477. So make sure you get the right chip. This is what it sounds like. I'll bring it a little closer. This is what it sounds like when you get real close to it, and it doesn't sound too bad. Haven't really set up the gain properly, but just for test. There you go. Doesn't sound too bad.